All right, subscribers, welcome back to another episode of Science with Surbeck. Today, what we're going to be doing is some extra gas law practice. So I'm going to do problems 1, 3, and 5, and then expect you to do the remaining problems. Okay, so problem number 1 states that the pressure of air in a 2.25 liter container is 1.20 atmospheres. What is the new pressure if the sample is transferred to a 6.50 liter container and the temperature is held constant? So remember with the gas laws, the key to being able to solve these problems is being able to identify what formula to use. Well, we have volume and pressure, and temperature is held constant. Now, this right here means that we need to use the following formula, and that is P1 times V1 equals P2 times V2. Okay, so now we'll just insert our values from our problem into that particular equation. So our first pressure is given at 1.20 atmospheres. And the volume that the air is contained in is 2.25 liters. So that 2.25 liters becomes V1. And then our P2 is what we're trying to find. It says, what is the new pressure? So our P2 in this case becomes our question mark. Now, our volume, it says that air is transferred to a 6.50 liter container. So our volume there is 6.50 liters. Now all we need to do is plug these values back into our equation. So we will take here our 1.20 atmospheres. So 1.20 atmospheres times our 2.25 liters, and this will be equal to our second pressure, which is what we're trying to find, P2, times 6.5 liters. Okay, so what we need to do for this problem is we need to get P2 by itself. So we divide by what it's attached, because it's attached via multiplication. So each side gets divided by 6.5 liters. Now, when we do this in our calculator, we need to put a set of parentheses around 1.20 and 2.25, okay? So what we do here, set of parentheses, 1.20 times 2.25, close the parentheses, divided by 6.50, and we press enter. Now we're going to round to 3 decimals in this case for this problem, so we get 0.415 atmospheres. And again, if you can't remember what the unit of pressure is, it should be the same unit of pressure. And that brings up a good point here. Remember, it doesn't matter what units we use in these problems, except temperature, which we'll get to in a second, but as long as our liters canceled, or as long as our volume unit canceled, it's okay to use that particular unit. As long as the pressure units are the same and the volume units are the same, it does not matter what we use. All right, let's move down to number 3. So it says a gas at 55 degrees Celsius occupies a volume of 3.6 liters. We want to know what volume will occupy, what volume of gas will occupy at 30 degrees with pressure remaining constant. So again, what we need to think of is, what do we have? Well, we have temperature and we have volume. So our formula, I'm going to write this out to the side, if you remember from notes, is V1 divided by T1 equals V2 divided by T2. Okay, so let's just go ahead, let's insert these numbers into what we have. So our volume number 1 is 3.60 liters. So V1 equals 3.60 liters. Our T1 is our first temperature, which is 55.0 degrees Celsius. And now we come to our first conversion. Okay, our temperature cannot be in degrees Celsius. It has to be in Kelvin. So what you need to do is you need to add 273.15. So I'm going to take this 273.15 and I'm going to put that into my calculator. So I'm going to have 55.0 plus 273.15. I press enter. And so the temperature I need to use is 328.15 Kelvin. And I'm going to write that just below here. So 328.15 Kelvin. Okay, and I'm going to underline that because that is what we are going to utilize here in a second. Now, it says what is our volume going to be, so our V2 is our question mark. So V2 becomes a question mark, but it says the gas is lowered to a temperature of 30 degrees Celsius. So our T2 becomes 30 degrees Celsius, but remember 30 degrees Celsius means we have to convert it to Kelvin. So what we're going to do to 30 degrees Celsius is add 273.15 to that number. So we take 30.0 plus 273.15. We press enter. Our second temperature is 303.15. So I'm going to put this below here, 303.15, and that is big K for Kelvin. Temp has to be in Kelvin. All right, so let's go ahead and plug these numbers back into our particular equation. And so we would end up with 3.60 liters divided by our T1 in Kelvin. So 328.15 Kelvin equals our V2 divided by our second temperature, which is 303.15 Kelvin. Okay? Now, what we can do here is this. I'm going to divide this business, 3.60 divided by 328.15, and end up with one number on our left. So again, 3.60 divided by 328.15. That right there, that's kind of an intermediate calculation for just this fraction. Then I'm going to take this number that's in my calculator and I'm going to cross multiply it with that second temperature of 303.15 Kelvin. So I'm going to take this, multiply it by 303.15 Kelvin. And I get a value, if I round to 3 total digits, of 3.33 for our second volume. So our V2 in this case is 3.33 liters. Now, it is not a problem here if you cross multiply both sides and then you solve algebraically. Or you could make life easy and you could, again, you see the fraction, you could take whatever is the fraction on the left and cross multiply it to solve for V2. Either way, you can get to the correct answer. Okay, so I'm going to do number 6 as my last example here. And it says, if a sample of oxygen has a pressure of 810 torr at 298 K, what will its pressure be if its temperature is raised to 330 Kelvin? So, again, we have to outline the players in the game here. We have pressure and we have temperature. So that means we're going to use P1 over T1 equals P2 over T2. Okay? So our first pressure, it says that gas had a pressure of 810 torr. And again, it does not matter. It does not matter the unit of pressure as long as it's the same on both sides of the equation. Now, our temperature is at 298 K. Well, that's nice for us because that means we have no conversions, and we can just write that down because that is in units of Kelvin. Now, our second pressure, it says, hey, what is that pressure? So that's going to become our question mark. And then our second temperature, it says the gas is raised to a temperature of 330 Kelvin. So our second temperature there, our second temperature, T2, is equal to 330 Kelvin. Okay, so we have all the players in the game. The temperature is in the right unit. We can plug these values back into our equation. So we're going to have 810 torr divided by our first temperature, which is 298 K, equals our second pressure, P2, divided by 330 Kelvin. This time, I am going to go ahead and cross multiply both sides. So I'm going to take 810 times 330 in my calculator. So 810 times 330 in my calculator. And I get this value here of 267,300. And that would be torr Kelvin. And then I take P2 times 298, and I end up with P2 times 298K. Okay? Now, what I'm going to do, because we need to get P2 by itself, we divide both sides by 298K. And so we divide both sides by 298K. And what I'm going to do, it's already in my calculator, 267,300. I divide that by 298, and my second pressure in units of torr is 897 by the time I round to 3 digits. So my second pressure, I'm going to write this above, is 897 torr. And it's torr because it has to match up with our units of pressure here. All right, so that's how we would solve. That's how we would solve each of the 3 gas laws. Again, I want you to do the remaining problems that I have not done on your own. I hope you have enjoyed this episode, and as always, if you haven't done so already, make sure you subscribe.